Hello students, nice to see you all again students. Today we'll be moving further ahead with certain good multiple choice questions, and these particular questions are related to your JEE mains as well as for your NEET, for your further preparations for your engineering entrance exams as well as for your medical entrance exam students on the platform of Synapse. Me, Ajit Dave, is going to be with you for another time, and we will be discussing with good amount of questions in that case, and certainly good questions where students certainly are not able to catch it at a particular moment or are thinking how to go about with it. Let us move further ahead with it. I'm trying to pick up those particular questions which has maximum weighted students for the chapters or the topics we consider related to your JEE mains and for your NEET students. Let me put forward a question related to your thermodynamics. So I'll put down the question, students, read the question very carefully onto the board, and we'll be solving for it. Is that clear? Let us go further ahead, students. Okay, students, I have put forward the question to you all, and this is a question related to your thermodynamics, and it's a question based on to efficiency of an engine. That's we can consider a kind of Carnot engine, we take it. Now, when you look at the question, students, just have a look at the question, students. It's written that there are 3 Carnot engines. Please, I'll read the question once for you all, okay, and then we'll move further at students. There are 3 Carnot engines operates in series between a heat source at a temperature of T1. Yani heat source, जहाँ पे the heat is supplied by the system we consider is at a temperature T1, and a heat sink we consider at a temperature T4. So there is a sink where the heat is being transmitted. We consider it's at T4 as shown. Now when I use the word as shown, that means how exactly you have the flow of the heat. We consider it's T1, T2, T3 and T4. This is how the flow I'll consider. So it's T1, T2, T3 and T4 students, that's how we consider. Now there are 2 other reservoirs at temperature T2 and T3 such that, students, the temperature of T1 is greater than T2, is greater than T3, is greater than T4. Now, these 3 engines are equally efficient. That's what I've given. That means if I happen to put forward regarding the engines, how do I consider 3 engines? We say that T1 is a heat source where the transmission of heat takes place between T1 and T2, so we can find out the efficiency with respect to T1 and T2, and then I put it as eta. The term eta is considered to be efficiency, students. It's eta1 we consider. During the transmission from T2 to T3, students, this efficiency is considered to be eta2 we take it, students. Whereas in the third case, students, if I happen to consider it's a transmission from T3 to T4, and that's eta3, students. So now when you look into the question that given to you, these 3 engines are equally efficient. यानी ये 3 engine equally efficient कभी होंगे? That's a question asked. Now if you see, there are 4 options given to you. Now when a student is observing these 4 options, what exactly options is actually speaking about? तो सारों में T2 को subject बनाना है. That is temperature for sink 2. यहाँ पे कहाँ पे? So यहाँ पे T3 का temperature के बारे में बताया. That means your concept or your solving part should be restricted to T2 and T3. Now when the students understand this, yes, it's a system consisting of 3 engines. T1 is a heat source, T4 is a sink we consider. यहाँ पे efficiency, eta1, eta2, eta3, and all 3 we considers what? That is, all 3 engines are equally efficient, student. That means now if I happen to go for the efficiency in that case, how do you go for the definition for efficiency, students? Efficiency of a heat engine we consider is equal to what? It's actually 1 minus temperature of the sink with respect to the temperature of the source we consider in that case. Please, students, it's temperature of the sink as with respect to the temperature of the source. Now when you look into it, अगर तुम T1 और T2 के बीच में देखोगे, T1 becomes a source, T2 we consider as a sink. If I consider between T2 and T3, students, T2 I consider as a source and T3 will be the sink. If I consider T3 and T4, students, तो T3 तुम्हारा सोर्स हो जाएगा, T4 क्या बन जाएगा sink? यानी यहाँ पे हमारे 3 reservoirs we consider, 3 engines are equally efficient. So we need to go for the efficiency in each case. So now if I happen to go for the formula for each case, then getting the efficiency in the first one. So efficiency for the first one is what? Formula will be moved. It's 1 minus temperature of the sink minus temperature of the source. Temperature of the sink minus temperature of the source. These two, temperature of the sink minus temperature of the source if I happen to consider. Then in this case, students, listen carefully. If I say temperature of the sink, the temperature of the sink क्या होगा? So temperature of the sink यहाँ पे आएगा T2. I getting it? So it's 1 minus T2 by T1 students. That's a eta 1. यहाँ पे eta 2 क्या होगा? What is eta 2 students? Eta 2 is what? So eta 2 if I have to consider, it's 1 minus. Can you give a relation now? So it's 1 minus what exactly you consider? So that is T2 by T1, so can I say that becomes T3 by T2? Because this becomes my source and this becomes my sink in that case. So it's T3 by T2. Likewise, what about eta 3, the efficient for the third engine we considered? So what exactly it's 1 minus, what exactly you consider will be? So ये source है, ये sink है. So can I say it's T4 by T3? So what exactly you are going to do, students? In this, you are going to consider that all these particular 3 engines have their own efficiency, but the efficiency of all these engines is the same. Have a look into it. It's equal. So now what do I do? So ऐसे करते हैं ना, equal है, तो equate करो. Eta 1 will be equal to what? Eta 2 is equal to eta 3. And equate the 3 equations. Now when I equate the 3 equations, what are we going to get it? So equating this, then you can say it's 1 minus T2 by T1 is equal to 1 minus T2 by T3 is equal to 1 minus T4 by T3. Now, what exactly I've said? This is simple maths. Because now when you look into it, your concept related to your physics is only up clear. Now what exactly you do? Simply go with your maths relation. So what's the relation you consider over here? So यहाँ पे हमें relation मिलेगा. Listen students carefully. It will be T2 by T1. That is equal to what we consider in terms of it. The second way is if I happen to consider T2 by T1, that will be equal to what? T3 by T2. Sorry, this is T3 by T2 we consider. That's the second one. So it's T3 by T2, which is equal to what? Students, T4 by T2 students. Can I say now all the efficiencies are equal? ये point मैंने कहाँ से लिया? So यहाँ पे all are equally efficient students. All are equally efficient. Now when I equate it, what exactly relation I'm going to get it students? So यहाँ पे आप देखोगे तो relation क्या होगा? So एक relation होता है T2 square students. क्या हो रहा है? T2 square is equal to T3 into T1. Second relation क्या आ रहा है? So T3 square is equal to what? T2 into T4. Is this clear with you all students? So now when you look at it students, I'm getting two such relations. Please have a look into it. I consider that the efficiency in the first case is equal to efficiency in the second case is equal to efficiency in the third case students. So now when I get all these particular 3 efficiencies, what exactly am I getting? So I'm getting it as what? T2 square is equal to what? It's T3 into T1. And the next expression which I'm getting it is what? 3T square is equal to what? Sorry, T3 square is equal to what? T2 into T4. Because all the three engines are equally efficient. Now I need to make T2 as a subject. Because तुम्हारे जितने भी options हैं वहाँ पे T2 एक subject है. So out of these two, any one answer you can find out. Any one answer. And see there is a variation. There is a variation in T2. One can easily get the answer accordingly. How do I go about it? Sir, हम यही expression लेते हैं. Listen students carefully. T2 square is equal to T3 T1. Now suppose if I happen to go for the same expression, what do I consider students? If I get this particular expression, T2 square is equal to what? T3 to T1. Can I take this raised to the power of 4 I can consider? Suppose if I happen to consider, इसको मैं लेता हूँ what exactly? So let us go for raised to the power of 4. तो जो T2 square होगा, ध्यान से सुना students. Raised to the power of 2 is equal to T3 into T1 raised to the power of 2. So can I say this becomes T2 raised to the power of 4 is equal to T3 square into T1 square students. Now carefully observe into it. Do you have T3 square? Yes. Look at the options. Look at the options students. सब में T2 तुम्हारा subject है, लेकिन T2 के साथ में T1 T4 T1 T4 T1 T4 T1 T4 T2 के साथ में T1 T4 आना चाहिए. हमें क्या मिल रहा है? T3 square. Can I substitute T3 square, students, back over here? Can I substitute this back over here? अरे हाँ सर, मिल गया तुम्हारा आंसर. यहाँ पे देखो, T2 raised to power of 4 is equal to, अगर मैंने T3 square को substitute किया तो ये क्या होगा? सिर्फ ये होगा T2 into T4 into T1 raised to power of 2. Is that clear, students? Now see carefully, observe it. ये है तुम्हारा T2, ये भी है तुम्हारा T2. If I solve this, this will be the denominator. So what exactly? A raised to n upon a raised to n. So this becomes raised to the power of 3 is equal to, what am I getting? So this is T1 raised to the power of 4. Sorry, raised to the power of 2 into what? T4, students. Now see over here. Can I take cube root on both sides? Can I take cube roots? So T2 will be equal to what? So it will be T1 square into T4 the whole raised to the power of 1 by 3. Did you get your one of your options? See, what exact option you got it? So we got the option is T2, yes, is equal to T1 square, yes, T4 is to 1 by 3, the whole raised to 1 by 3, students. That means out of these particulars, if you look into it, this is only one option which is trying to match up with this. Can I get the second one? Yes, why not? तो ये second option ये वाला भी मिल सकता है. कैसे मिलेगा? So try to substitute the value of T3 in that case. But when you're looking into it, when you have all these options of T2 and T3 to consider, and one of the answers is matching it, then what exactly answer for this will be? Option B. You want to work out for T3 in that case. But if one wants to solve it, yes, can easily be done simply by using the relation. So when you're getting 4 options, and out of 4 options we consider the subject is T2 in all the cases, students. Subject में subject T2 है. Variation देखो यहाँ पे T1 क्यूब है, T1 square है, T1 है, T1 है. लेकिन यहाँ पे T1 square, there is no other option of T1 square. Am I getting T1 square? Yes. आ गया मेरा आंसर. T4 एक है. लेकिन ये क्या है? raised to the power of 1 by 4, 1 by 3, 1 by 2. अगर ये लेता हूँ इसके साथ में, लेकिन अगर T4 raised to the power of 2 आ रहा है, T4 raised to the power of 1 आ रहा है, तो can I say this answer is my precise answer? इसको solve करने की जरूरत नहीं होती है. You can save your time and jump on the next question. हाँ, अगर तो suppose तुम्हारी ऐसे 2 options match होते हैं, then you have to go for T3. And now if I want to go for T3, take this particular relation and put in the values over here. So this part is clear with the students. This was a simple numerical based on your Carnot engine we consider. जहाँ पे बताया था कि efficiency for all these particular regions is the same. It's equal in that case. The temperature of T1 was greater in comparison to T2. T2 was greater than T3. T3 was greater than T4. Eta we symbolize as efficiency, and efficiency simply we consider as what? It's 1 minus temperature of the sink to the temperature of the source. Hope this part is clear with the students. Now after this, let us go for next question. The next question I'm going to pick up will be a simple question related to your kinetic theory of gas. Let me pick up a simple question, and hopefully I think that we'll be able to catch up this particular question also. Okay, so just have a look at this, and then we move further for the next question. Okay, students. Now we go for the next question. Okay, the previous one was based on the thermodynamics, students, and now we are going to go for a very short and a simple conceptual question. But yes, many students do not figure it out how easy the question is. The time when they go on reading the question, they literally forget the main hint given within the question itself only. And the solution becomes very easy when you understand the question properly. Now, have a look at the question, students. It's based on your kinetic theory of gases, students. Question ये है कि there are 2 glass bulbs. 2 glass bulbs दिए हैं, जिनकी volume same है, they are equal volume and connected by a narrow tube. अभी जो tube दिया है, if you carefully look into it, उन्होंने बोला the volume of the connecting tube is negligible. That means you are not going to consider the change or the effect of change in volume with respect to change in pressure, because there is no volume considered in that case. It's negligible we consider. Okay, so now if I happen to consider when the gas is getting transferred to this particular negligible volume we consider, we are not going to consider the effect of change in pressure. When you have the gas getting transferred, that is what we consider from a higher temperature to a lower temperature we consider. So there is some amount of gas which is getting diffused we consider. So now when you look into it, two glass bulbs of equal volume are connected by a narrow tube and now filled with gas at 0 degrees Celsius and a pressure of 76 centimeter of mercury. Yani pressure has 76 centimeter of mercury, of course. The mercury barometer, Fluorine's barometer is used to measure the atmospheric pressure, so 76 centimeter of mercury. One of the bulbs is then placed in melting ice. एक बल्ब को कहाँ पे रखा है? Melting ice. और दूसरे वाला को कहाँ पे रखा है? It's placed in water bath and maintained at 62 degrees Celsius. यानी एक बल्ब को high temperature में रखा है, दूसरे बल्ब को low temperature में रखा है, और वहाँ पे है क्या? Inside what exactly it is? So the two glass bulbs equal volume are connected by a narrow tube and are filled with gas. At what temperature? 0. And what exactly the pressure is? 76 centimeters of mercury. Now what's the question asked? What is the new value of the pressure inside the bulbs? The new value of the pressure inside the bulbs in that case, considering the volume of the connecting tube to be negligible. Now look at the options. Options we consider is what? 73.83. Now option B 83.83. 93.93, 103.03. Now when a student is observing the options also, what do you consider? Sir, initially pressure there is 76 centimeters of mercury. Option A may there 73.83, so will I have a pressure decreasing in that case? No, there will be transfer of number of moles in that case. So will not be. That means my answer should be greater than 76, but certainly less than 103. That means my answer will be between B and C itself only. Now when I speak about it, let us draw a small diagram to understand this concept. Suppose if I happen to go for it, let me consider these are the two bulbs, and these two bulbs are being connected by a small tube we consider. Now one of the bulb is at 62 degrees Celsius. Now suppose if I happen to go for its temperature, so can I speak about in Kelvin we consider? Yes sir, so I added 273. So if I added what exactly consider will be degree Celsius to Kelvin, students add 273. So 5, 335 Kelvin we consider. दूसरा वाला कौन सी टेम्परेचर है? सर 0 डिग्री सेल्सियस है. Can I convert to Kelvin? हाँ सर, add 273. ये कितना होगा? सर 273 Kelvin. यानी पहले क्या था? पूरा गैस है at 0 डिग्री सेल्सियस, लेकिन now what they are doing it? सर एक वाले को 62 डिग्री के अंदर रखा हुआ है. और दूसरे वाले को कहाँ पे रखा है? सर ice, melting ice, 0 degree. Means can I say this is at a high temperature and this is at what? Low temperature. Let n be the number of moles in the first case. Let n be the number of moles in the first case, students. Now students, when somebody is using the equation of state of an ideal gas, what exactly an ideal gas equation we can consider? Students, listen carefully. Then the equation will be PV is equal to nRT. Condition 1. ध्यान से सुनो students. Condition 1. पहले क्या बोला था कि दोनों bulbs के अंदर gas is present at 0 degree Celsius and pressure is 76 centimeters of mercury. तो ये जो statement है, based on that, I'll get my first equation. What is my first equation? So if you look over here, the pressure if I have to consider is what? It's at 76 centimeters of mercury I'll consider. Volume I'll consider as V. Let's take the number of moles will be N. Capital R is what? The universal gas constant. Temperature is 0 degrees Celsius. Can I say 273 Kelvin? And that becomes my equation number 1. Hope this part is clear with the students. So first equation is what? 76 into V is equal to N into R into 273. Now look at the next part of the equations. जैसे तो प्रॉब्लम को आगे बढ़ते हो तो उन्होंने क्या बोला है? एक बल्ब को रखा है 62 डिग्री सेल्सियस के अंदर, दूसरे बल्ब को रखा है मेल्टिंग पॉइंट ऑफ आइस. यानी one is at a high temperature, the other one is at low temperature. What is going to happen, students, in this case? Get you know what's going to happen? So there will be transfer of number of moles. That is, the gas molecules will certainly move from where to where? From a high temperature to a low temperature, and that is due to the difference in temperature. Let us say that X number of moles, the answer is in our student, let us say that X number of moles get transferred from high temperature to low temperature. अगर suppose मैंने बोला आंसर देखना, अगर यहाँ से मैंने बोला X निकल रहा है, X number of moles are been moving out, तो यहाँ पे कितने बचे? N minus X, क्योंकि number of moles दोनों में N है. अगर suppose N minus X यहाँ से निकले और यहाँ पे X पहुँच रहा है, तो यहाँ पे कितना होगा? सिर्फ N plus X होगा. यानी ये 60 डिग्री सेल्सियस के लिए और ये 0 डिग्री सेल्सियस के लिए. इंस्टेंटली जैसे मैंने नंबर ऑफ मोल्स डाल दिया, स्टूडेंट हु स्मार्ट इनफ टू इंस्टेंटली कह रहे हां सर अभी आपको दो और इक्वेशन मिलेंगे. एक होगा बल्ब एट हाई टेंपरेचर, दूसरा होगा बल्ब एट लो टेंपरेचर. नाउ कैन आई अगेन यूज द इक्वेशन ऑफ स्टेट एंड गेट द टू इक्वेशंस. See how to work out of it. So when you look into it, I'll get two more equations. And then I'll get this equation. Let's go to the next equation. What is the next equation? So यहाँ पे हमें pressure find out करना है, तो कहना है P dash into volume is V itself only. No change in volume. For this, the transfer of number of moles is what? So it's equal to decrease by N minus X. Capital R. What's the temperature? So it's 335 Kelvin. That's my equation number 2. Hope this is clear with the students. On the other side, let us say the pressure inside the bulb is P dash, volume is V. यहाँ पे क्या होगा? सर जब X molecules निकलते हैं तो यहाँ पे कितने होंगे? सर N plus X into capital R into what exactly? So 273. That's my equation number 3. Now have you got it? That means when a student is reading this particular question, when the student reads a question, he finds out the question is too huge enough. But as you go on reading this question very carefully, एक पहला condition दिया है जहाँ पे 0 डिग्री सेल्सियस 76, तो ये तुम्हारा इक्वेशन है. दूसरे केस में दिया है कि ट्रांसफर ऑफ मैटर हो रहा है फ्रॉम हाई टेम्परेचर टू लो टेम्परेचर, तो नंबर ऑफ मोल्स भी ट्रांसफर होंगे. अगर x मोल्स यहाँ से ट्रांसफर हो तो यहाँ पे कितने बचे? n minus x, because initially was n. यहाँ पे कितने होंगे? n plus x, तो उनका भी इक्वेशन होगा. जैसे तुम्हें तीन इक्वेशन मिले हैं, all those three equations are considered from where? From equation of state of an ideal gas. Now what exactly? Simple maths. अब यहाँ पे पूरा maths हो गया, physics हो गया तुम्हारे यहाँ पर. The next part is your maths calculation, and that's what we say that a person who's good in maths will certainly be able to crack multiple choice questions much more easily, students. क्योंकि यहाँ पे अगर तुमने errors कर लिए, then you are gone. You're not able to get those particular answers more correctly in that case. So now how do you go about it? सर हम लोग ऐसे करते हैं, आपको P dash पूछा है ना, तो हम करेंगे क्या? सर ऐसे करते हैं, सेकंड इक्वेशन और थर्ड इक्वेशन के दोनों का रेशियो लेते हैं, ये पूरा कैंसिल हो जाएगा, हमें n minus x और n plus x का रिलेशन मिलेगा, and then can I put it into one of the equations? Yes, why not? So now when I go for it, what do I consider? Take the ratio. Suppose if I say divide 3 and 2. Let's divide 3 by 2, we consider. Third equation by 2. So now can I say, if I divide this, P dash V, are you getting it? Will get cancelled in that case. Are you getting it? So now if I happen to consider this, can I say, I can equate both of them, I can take it. So now what exactly the equation I'm going to get it? So if in case if I happen to consider the equation will be what? Please students, the equation which I'm going to get will be what? N plus x. Is that clear? Both of them are equating capital R into 273. Either divided or I can equate it also. Because left hand sides are equal, I can equate right hand sides also. That becomes much more easier. N minus x students into capital R into 335 students. Now when you're solving what exactly is the capital R gets cancelled. ये क्या होगा? So it's n plus x upon n minus x will be equal to how much? So 335 upon 274. Is this clear with you all? Now what do I do? So यहाँ पे हम component में divider लेते हैं. तो यहाँ पे क्या होगा? सर यहाँ पे होगा 2n, ध्यान से सुनना, कंपोनेंट में एंटीसीडेंट प्लस कॉन्सिक्वेंट अपन एंटीसीडेंट माइनस कॉन्सिक्वेंट, जो स्टूडेंट्स बोलते हैं न्यूमरेटर प्लस डिनोमिनेटर अपन न्यूमरेटर माइनस डिनोमिनेटर स्टूडेंट्स. तो जब भी हम करेंगे तो ये 2n होगा, नीचे होगा 2x, इन दोनों को ऐड करो. सर 5 plus 3 is 8, 7, 8, 9, 10 and 1, 11, 3, 4, 5, 1, 6. Subtract and get this 2. 7 and 6, 13, so 62 I'm getting it. 5 and 3, 8, I'm getting it 7, 8, 9, sorry, this is 0, carrying over 1, 608 upon 62 students. Hope this part is clear with you students. So now when I'm looking into what exactly I'm getting it, I'm getting this as a ratio. Now students, this 2 will get cancelled. How do I go about the solution from here onwards? Now see, if I want to match up with the answer, what I'll do, you know, these 600 in here 62 नहीं दूँगा. मैं ये पूरे को assume करूँगा कि ये 600 है. To make my calculations more easier. ये जो 62 इसको मैं क्या assume करूँगा? 60. आंसर सुनो students, 0 and 0 gets cancelled. बचा क्या? 10. Agreed? So what is n by x? 10 by 1. What is n by x? 10 by 1. What I need to find out? What I need to find out, students? So I need to find out in terms of what? So I need to find out a relation with respect to p dash. Now how do I go about it? n by x is equal to 10 by 1 we consider. Where exactly I'm going to substitute this? So either you can consider ratio of 1 by 2 or 1 by 3. You can get the answer. मेरे को 3 और 1 को मैं लेता हूँ. The answer सुनना, p dash into v upon 76 into v is equal to n plus x r into 273 upon n into r into 273. यानी क्या किया मैंने students? मैंने equation number 3 और equation number 1 का ratio लिया है. Now students से सर आपने 2 और 1 को क्यों नहीं दिया? ले सकते थे, लेकिन ये दोनों numbers अलग ही उठाएगा 335. That makes your my calculations more tricky. यहाँ पे देखो, ये 7 से ये तो कैंसिल हो रहा है. ये भी क्या है? ये भी कैंसिल हो रहा है. ये क्या है? ये भी कैंसिल हो रहा है. आपको चाहिए क्या था? वहाँ से p dash चाहिए था, वो तो मिल रहा है. तो ध्यान से देखो, p dash upon 76 is equal to, ये क्या है? n plus x upon n. n plus x upon n, students can I write 1 plus x by n? 1 plus x by n. What is n by x? 10 by n. What is x by 10? 1 by 10. तो अगर इसको मैं सॉल्व करूँगा 1 by 10, ध्यान से सुना students, 1 by 10, 0.1, 0.1 plus 1 कितना होगा? 1.1. तो ये आ गया 1.1. तो p dash की वैल्यू क्या होगी? 76 into 1.1. Now students can tell me which option matches up with this. So students कह रहे हाँ sir, आपने बोला था A तो already ruled out हो गया था because original question was 76, so this cannot be the possible. 103 cannot go beyond 76, and then it cannot go beyond 100. In that case, I consider my answer to be between 83 and 93. Now see over here, 11 6 are 66, 11 7 are 77, 77 plus 6 will be how much? Around 83. Am I getting my answer near 83? Yes. So what's my answer will be? Option B. So we are students, when we are solving such kind of questions, try to think properly. First part is what? Simply go for an equation instead of an ideal gas. Get the two equations, because I've said it that the two which is connecting of negligible volume, so we're not going to consider any change in pressure. The number of moles which are transmitted from a high temperature will be n minus x left behind, and the other will be n plus x. Use the equation of state for both the cases. चाहिए क्या था? तुम्हें p dash चाहिए था, लेकिन यहाँ पे तुम्हें दो वेरिएबल्स है, तो सबसे पहले तुम इन दोनों को डील करो. या तो तुम रेशियो लो, which I wrote it first, but then I said it, go for equating the two. क्योंकि left hand sides are equal, तो right hand sides are equal, तो मैंने दोनों को equate कर दिया. यहाँ पे मुझे n minus x की वैल्यू मिली. यहाँ पे भी तुम्हारी 60862. If I try to solve it, I'm getting the answer which is, but no need. Go for 660. Try to make the calculations more easy. Get the ratio of n by x. Then what do you do? So first and third equation को लेगा. Then I get the ratio of that, substituting that, I'll get the option this option. Hope this part is clear to students. So it's a question based on your family theory of gases, students. Okay. Now we move further ahead, students. After KBG, the next question which we are going to pick up will be, let's go for a question related to optics. Hope that you're able to catch this particular question very properly. Okay, let's move ahead with optics. Now this is one of the question which most of the students must have come across. But over here, when you look into this particular question, students, there are a few concepts involved into this particular problem. and that's why most of the students try to struggle with such kind of problems. And very important, if you look at the option students, look at the option B in this case, they've given none of these. Okay, so let us read the question and then I'll speak about none of these. Please pay attention, students. The question is based on two optics, students. The question is, a glass prism of refractive index 1.5, that means 3 by 2, is immersed in water, and let's look at the diagram. It's a glass prism of refractive index 1.5 is immersed in water, and the refractive index of water is 4 by 3, that's 1.33. A light beam is incident normally, that means at an angle of 90 degrees on the face AB. On the face AB of this particular prism we consider is, okay, and it's reflected to reach the face BC. It's reflected to reach the face BC. Is that clear? If that means this particular light is getting reflected to reach the face BC, conditions kya diya hai? If sin theta is greater than 8 by 9, sin theta is greater than 2 by 3, less than 8 by 9, sin theta is less than 2 by 3, and option D is none of these. Students, यहाँ पे जब option none of these आता है, then it becomes necessary for one to solve the entire problem, students. You can just try to get the answer. And suppose अगर यही question पीछे वाले problem हम लोगों ने किया जहाँ पे 83.33 आ रहा था, अगर और नीचे none of these आ रहा था, ध्यान से सोचना students. अगर suppose fourth option यहाँ पे none of these होता, तो take it from me, students. I had to solve the entire solution. The ratio was somewhat 608 upon whatever you got it. We got the decimal in that case, and I could have reached that 83 point something correct answer. अगर वो नहीं बोलता, then my answer would have been none of these. So please do take care of it. When none of these are given to you as an option, so you need to solve the problem. Now, secondly, when students are looking at this, many of the students will say, "Yaar, it's 8 by 9 is somewhere a fraction which you've come across. 8 by 9 is a fraction which you've come across." If I happen to consider 4 by 3, if I consider 4 by 3 into 2 by 3, then 4 by 3 upon 3 by 2. ध्यान से सुनो students, mental maths कर रहा हूँ मैं. 4 by 3, 4 by 3 upon what exactly consider in that case? Sir, in that case 4 by 3 into what exactly consider will be 3 by 2 I consider divided by 3 by 2. तो it will be 8 by 9 हो जाएगा. 4 by 3 किसका है? Refractive index of water है. 3 by 2 किसका है? Refractive index of glass है. समय दोनों का ratio होना जरूरी है. Let us go for this. Now when you look at the question, the ray of light is incident normally. Now when you draw this diagram, it's a very simple question to understand. Let us say that this was the triangular portion you consider. I'll just take the triangle part of this, okay? ये तुम्हारा 90 है, ये angle theta है. This is A, this is B, and this is C. I'm just trying to magnify this value. अगर suppose मैं magnifying glass से देखूँगा तो थोड़ा सा बड़ा मैंने बना दिया है. बाहर की तरफ क्या है? Sir, ये water है. And this is the level of water. Let us say this is the level of water. Consider. Now, if I make a ray of light as incident normally, students, these potential students, अगर मैं normal लिया तो कैसे जाएगा? A ray incident normal to any of the refracting surface will not move or will not change its path. That means will go undeviated, and this is because of the concept of symmetry. ये ध्यान में रखना students, ये symmetry का concept है. यानी बहुत सारे स्टूडेंट्स आर थिंकिंग दैट मैनर कि अगर सपोज मैंने रे ऑफ लाइट इंसिडेंट नॉर्मली ले लिया, यानी जा रहा है एयर, प्लीज पे अटेंशन, जा रहा है एयर इनटू व्हाट? ग्लास. एयर टू ग्लास. एयर टू ग्लास इज ट्रांसमिटिंग स्टूडेंट्स. अगर वो एयर टू ग्लास जा रहा है तो बेंडिंग होना चाहिए, रिफ्रैक्शन होना चाहिए, लेकिन फिर भी वो सीधा जा रहा है. क्यों ना रिफ्रैक्ट होगा? होगा स्टूडेंट्स, लेकिन यहाँ पे पॉसिबिलिटी हमें नहीं पता. अगर मैं बोलूँ रिफ्रैक्ट हो रहा है तो if I have to behave in this case, शायद it can go in the direction away from this, or it can go in the direction away from this, or it can go towards this or towards this. यानी दो possibilities है. अगर दो possibilities मिल रही हैं on either side, so we are unsure where exactly it is. Therefore, by symmetry we say that the ray of light will move undeviated. ये ध्यान में रखना, ये है concept of symmetry, which we use it in refraction. Exactly same concept of symmetry we use it in current electricity, students. शायद तुम लोगों ने देखा होगा करंट में भी, अगर सपोज यहाँ पे आ रहा है तुम्हारा रेजिस्टेंस है, अगर सपोज इफ आई से ये भी 2 ohms है, ये भी 2 ohms है, and now suppose if I say current capital I is reaching at the junction, ये तुम्हारा junction है and the current is approaching the junction. What exactly the Kirchhoff law you have come across? Kirchhoff law क्या पढ़ा होगा? So Kirchhoff's first law speaks about current law, law of conservation of electric charge. That means as many charge flowing through the junction per unit time is exactly equal to that many charge leaving the junction per unit time. Thereby, there is no accumulation of electric charge at the junction. अभी यहाँ पे क्या होगा? सिर्फ ये 2 ohms है, ये भी 2 ohms है. यानी हमने ये रेजिस्टेंस को सेम लिया, लेकिन शायद पॉसिबिलिटी ये भी होगा कि करंट शायद यहाँ पे और यहाँ पे सेम इसलिए जा रहा है कि ये सिमेट्री है. अगर सपोज ये रेजिस्टेंस ज्यादा होता तो यहाँ पे कम करंट जाता, यहाँ पे ज्यादा जाता. अगर यहाँ पे रेजिस्टेंस कम होता और यहाँ पे रेजिस्टेंस ज्यादा, यहाँ पे कम, यहाँ पे ज्यादा. लेकिन ये सिमेट्री का कांसेप्ट है. सो व्हाट्स गोना हैपन? द करंट फ्लोइंग विल बी द सेम. सपोज अगर मैंने यहाँ पे लिया I1, what exactly I consider will be I minus I1 and take it, but the current in both the cases will be exactly same, and that's your concept of symmetry. तो यहाँ पे students can be going for concept of symmetry itself only. So with respect to symmetry, what exactly will do it? So ये जो ray है वो सीधा जाएगा और हिट करेगा यहाँ पे. ध्यान से देखिए students, यहाँ पे हिट करेगा. Now look over here. A light beam is incident normal on face AB and is totally reflected. क्या the word you said? Totally reflected to reach the face BC. ये तुम्हारा face BC है, ये पूरा रिफ्लेक्टेड होना चाहिए. यानी स्टूडेंट्स यहाँ पे टोटल इंटरनल रिफ्लेक्शन होना जरूरी है. कैसे होगा यार? What are the conditions for TR यार? So conditions of TR पहला वाला क्या होना चाहिए? पहला कंडीशन ये है, the ray, the oblique ray students, ये ध्यान रखना, oblique ray should travel from optically denser to optically rarer. This is very important. अगर मेरे को टोटल इंटरनल रिफ्लेक्शन के बारे में पढ़ना है तो मेरा रे शुड ट्रैवल फ्रॉम ऑप्टिकली डेंसर टू ऑप्टिकली रेयर. ये पहला कंडीशन जरूरी है. दूसरा द एंगल ऑफ इंसिडेंस. ध्यान से सुनना, इन द डेंसर मीडियम स्टूडेंट्स द एंगल ऑफ इंसिडेंस शुड बी ग्रेटर देन द क्रिटिकल एंगल. तो ही तुम्हारा टोटल इंटरनल रिफ्लेक्शन होगा. तो यहाँ पे देखो, अभी ये रे यहाँ पे स्ट्राइक हो रहा है. सपोज अगर मैं यहाँ पे परपेंडिकुलर ड्रॉ करूँ जो कि नॉर्मल है स्टूडेंट्स, एग्री? ये भी 90. ध्यान से सुनना, ये थीटा, ये 90, तो ये कितना होगा? How much is this? 70 minus theta. सब ऑफ आगे से बताएंगे. अगर ये 90 minus theta है और ये मैंने 90 ले लिया तो ये कितना बचा? सर ये थीटा हुआ. यहाँ पे क्या हो रहा है? सर अगर ये रे, suppose if I take this as point x and if I take this as point y, the ray is reaching at point y. At point y, what's going to happen? So total internal reflection हो रहा है. क्यों हो रहा है? क्योंकि सर ये ग्लास है, बार पानी है, रिफ्रैक्टिव इंडेक्स ग्लास का ज्यादा है एज कंपेयर टू वाटर. तो होगा क्या? टोटल इंटरनल रिफ्लेक्शन एंड द रे ऑफ लाइट इज कमिंग थ्रू BC. This is theta, this is also theta. Now let us go for the condition. Where exactly ray of light? Suppose if I say refractive index, please pay attention students. Refractive index, if I happen to consider of water with respect to glass, then it will be what? So the sine of critical angle, which is also equal to what? Refractive index of water upon refractive index of glass. Please students have a look into it. Refractive index of water with respect to glass, यानी the ray of light is traveling from where to where? From glass to what? Optically denser, traveling to optically rarer in that case. That's sine IC, and that is equal to mu W upon mu G. What exactly mu W? What exactly mu W क्या है? Sir mu W refractive index of water. Water का refractive index कितना दिया है? Sir ये 4/3 दिया है. तो can I put 4/3? हाँ sir. Refractive index of glass कितना दिया है? 1.5 students. देखो भैया, it's 1.5. So can I say this is 3/2? अगर मैं इसका आंसर निकालूं तो 4/3 divided by 3/2 means can I say 8/9? और तुम ध्यान से देखो, ये IC क्या है? क्रिटिकल एंगल. यहाँ पे क्रिटिकल एंगल कौन दिखा रहा है? सर ये है तुम्हारा क्रिटिकल एंगल. Angle of incidence. The answer is the critical angle. Angle of incidence in the denser medium, for which the angle of refraction in the rarer medium is 90 degrees, for as critical angle we consider. And in this particular sine IC is 8/9. But is this angle greater than this? Yes, sir. My sine theta should be greater than sine IC. Why? Because the condition over here is total internal reflection. Now see, sine theta is greater than sine of IC. What's the value of sine of IC? 8/9. So can I say my sine theta is greater than 8/9? Which option shows me that? Option is A. So please, ये जो theta है, this is your angle of incidence. but it can be critical only when the ray of light is going grazing. यहाँ पे ग्रेसिंग नहीं हो रहा है, यहाँ पे TIR हो रहा है स्टूडेंट्स, TIR हो रहा है, तो ये जो मेरा एंगल ऑफ इंसिडेंस है वो क्या होना चाहिए? See, मेरा एंगल ऑफ इंसिडेंस शुड बी ग्रेटर देन क्रिटिकल एंगल, यानी sin थीटा शुड बी ग्रेटर देन sin ऑफ IC. sin ऑफ IC का आंसर क्या मिला है? 8/9. So what exactly answer will be? Sin theta should be greater than what? 8/9. So these are the few things which the student should keep in mind while solving questions related to refractive index and based on the total internal reflection. Hope you have understood this question, students.